So that thing is very much consequence that what smart grid is, that we need to know first. So if we understand what smart grid, then we can how to use it and why we require data science on it. So I will definitely give you some insight in practical notation as well. But before that, I want to start with the basic definitions. So smart grid. So grid, we already know about it. And as I knew, the host institute is SRM Institute in Katankulatut. And I remember I was in Chennai in 2011 or 12, I guess. On that time, there is a power outage in Chennai. And trust me, I was nearby the SRM Katankulatut. I remember the door still now. I was staying in VGN, one flat in VGN, just opposite to the SRM Katankulatut. And usually, what is happening, we can say the timing by checking is there any power or not. So that was happening in real time scenario. So there is a too much of current outage. My flat do not have the generator, so you always need to have based on the inverter. I remember those days. And it is very interesting. Like in summertime, it is very hot in Chennai. I'm not saying that Delhi is not too hot, but Delhi is also hot. But summer, Chennai is too hot. So on that time, we really calculate the time. Like on that time, what happened? 2 hours power on, 1 hour power off. 2 hours power on, 1 hour power off. I'm not sure. I think now it has changed a lot. But on that time, it was happening. So it is the main issue of the gridding in normal grid. In normal grid, we do not have any plan or any particular requirement how much power we require to process in a city or in like a Tamil Nadu like area like where lots of manufacturer companies there, lots of IT companies there. Obviously, there's a lot of IT hub is there, including Accenture, TCS, CTS, two TCS campus, Infosys in Jungle Pet, near to Jungle Pet. So there is a lot of electricity is required, but the scenario is very limited that we do not understand what time the peak time will be there and what can be the consequences. And that's the same thing also happening in China in some years back. China is also having some time uh, black black stage due to the outage of the power. So in this scenario, in this case, we require something smart. And how it make a smart? To making a normal grid system or a normal stationary system, to make it smart, we need to have a IoT system proper. And that IoT system works with the devices so that we can get a data, real-time data. And based on that, we can manage it. Even it also helps to found some outage. Suppose there is an outage due to some happening in because in Chennai or in southern part, when I am from West Bengal, in these parts they always have a cyclone type thing. So if there is something misbalances happened on that time, it is difficult to understand how it will go on again. Also, we also have like solar plant nowadays. We have wind turbine in few areas. We have um, thermal power and hydropower, that is already our old sources. Along with, we also have a atomic power. But all of this power has some own limitation. Specifically for the renewable energies, they have some limitations. But if we can wisely use our power, it can be a very good solution for our humanity. Specifically, I give you the first example in Tamil Nadu on that cases. I'm not sure. Is that in very good in Tamil Nadu at this moment? In Chennai, specifically in the Patheri area? If anyone over here from the Patheri area, let me know how it is in Patheri area at this moment. I really want to know because it is a very old place. Though I visited Chennai 2 days back, and that was really good. Not too much of power cut, but it's okay. But power cut is happening. So that's the for this type of scenario, we can expect a smart grid system so that it can work properly. So smart grid work in two-way communication. What is a two-way communication? First is real-time monitoring, and second is control. So real-time monitoring means what is happening at this moment, how it can be done, and what is the control. That means if there is something imbalance or something in peak, we can immediately balance it with some other sources. So that type of thing. Also, nowadays we can also in another one process is done, that is EV. Lots of EV is purchasing, person is purchasing EV. So on that time, EV also required a charging. How did you process it? So that is also our demand comes in. So demand can be increased. Suppose you have a family in somewhere in Kerala or somewhere in Bangalore. They suddenly came to your place. Maybe 10 to 15 car came to in your place. On that time, demand high. But that is not planned previous, right? So IoT devices can help to give this type of data. Next, the compliance. Compliance of whom? Compliance of user. So user means suppose that I told you, that problem I told you. If I call to the Chennai power team and I ask them that solution, they said there's a power outage. But how much time? I give you the specific time, 2 hours power on, 1 hour power on. So that basically the inconvenience happened to the user is not at all acceptable situation. So as it can be minimized, I'm not saying it can be off totally, but it can be minimized, right? So based on that, based on the data, based on we have, if we process it with a machine learning or AI, it can be a very good, reliable and quality solution. And that actually help us to increase our asset devices like our mm, IT companies. They can get power on time. They do not require too much of generator that actually fuel up our scenario. So these type of scenario can be monitored using this. So this is happening at this moment in in China, in Europe, in some places, Belgium specifically. They switch in between renewable power and the traditional power method. They do switching because during the winter time in Belgium, during the winter time, I was in Ghent University. In winter time, it is very hard to get sunlight. So on that time, it is much more need to be balanced. So this type of scenario, this type of sequence can be happen over there, and that only possible if normal start working with the IoT. These IoT devices actually give us the data and help us to analyze the data. So IoT specifically is not in a single device. It have lot of sensors. It have a lot of monitoring tools. It have lots of devices like an Arduino, Raspberry Pi, and then Node MCU, lots of things. Node MCU also specifically used for the data which can be monitored throughout the remotely. So you can push the data from IoT to the internet so that you can check it from a server room. So practically, what we are looking for in smart grid, we need to solve this whole power problem for a city, for a society, for a something without going outside or without knowing the scenario. Suppose there is a simple power cut and I am looking for a wire changes. It is not the way to find out. So these type of scenario we can overcome. Like if there is a cyclone warning is there, we can immediately stop the all power. It actually not only save our scenario, it also saves the life. So for this reason, smart grid is more acceptable alternate that we can have. So next thing in smart grid, what we usually look for? We usually look for few things. One is our timestamp. And what is actually the timestamps? It basically says how many time we required to put a resolution or to put the power back again based on the daylight rules, based on the lots of rules that we require. Next, the figure ID, which is very important thing. Feeder ID, transformer ID, and meter ID, they both are looking for the smart meter system that India is already introduced nowadays. You can see in Delhi, in Kolkata, in Chennai, in Mumbai, they introduce a smart meter. So previously, what happened? Previously, person came to your home, they read the reading, then the bill come in. But nowadays, it is not like that. It is most likely automated. So the reason doing the automatic is not the killing a person job. The automated to make it the outage flag or a event marker or a any kilowatt loss or any weather scenario comes up, any holiday calendar, any tariff windows, this type of scenario. Specifically, if I say an example of daylight saving rules, in Europe and New Zealand, they also have a biggest scenario like Japan. After 8 o'clock, Japan is almost slept. They all so and what Japan do actually after 8 o'clock to try to minimize the electricity for their essentials. They try to mitigate the local areas. So this is a rule in Japan that after 8 o'clock you cannot make any loud sound in your home. Otherwise police can be coming to meet with you, have a tea with you. And it also has a rule that after 10 o'clock you cannot, after 8 o'clock you cannot loud with your family member. If you loud, your neighborhood can complain on police. So these type of scenario, so that I know, like low area sun is there means where the in the area where all 8 o'clock will be split. On that time, they can reduce the power over, but in the same they can increase the power on the IT sector who are live at night. So these type of scenario, like weather and everything, that we can monitor through the smart data. So smart data also help us for the time zone, specifically for US type country where not a single time zone is followed. There is a three or four time zone is there. Specifically, also I can mention the name of Australia. Australia has three time zone, so it has also difficulties over there. So on that time, one one particular few hours they reduce the load in some areas, and that only possible when you know your transformer ID, your feeder ID, and the meter ID. Suppose how this is connected: transformer connected with the main network. From some feeder is connected to the transformer, and some meter is connected to the feeder. So if meter load is low, feeder will ask to reduce the load, transformer reduce load. So main power station will reduce the load on the main section. So that is also kind of like a load balancing we do in the cloud computing. So we do the load balancing in cloud computing when we publish a website or when we do something. On that time, we do that. We everybody do. As a IT engineer, it is our job to do that one. So this type of scenario we can manage with the smart grid system. So this is actually the smart grid. Now my point is why the data science or a data visualization is required of the smart. Now I will show you something, just a quick feed, then I will come back to this part. After that we can discuss with you definitely. So just give me a moment. I just open a data for you. So I open a simple data. Why the data science is required? Now I'm coming to the part of AIM. Previous I will just give example. IoT devices, sensors give me data like this. I took this data from a Kaggle, though this type of data we usually get. So this is a timestamp. I hope everybody can see my screen. So this is a timestamp. This is a voltage. This is a power consumption. This is reactive power kVA, kilo volt, power factor. I took solar power, I took wind power, and then the main grid supply, voltage fluctuation, overload, transformer for temperature, humidity, electricity, price, and prediction, predicted load. So that we will take as a column. And usually that we get it from the data. When you put any kind of like a sensor, like how much solar power I required on that particular time, we can get it easily. So this is the voltage we require, this is the ampere we require, this is the power consumption, and based on that we can calculate the rest of that part and what we have. So suppose there is a actually there is a need we need to balance something. What we need to balance? We need to balance the power based on our requirement and our availability. So that basically a mapping needs to be done. Now, can it done manually? Yes, it can done. Previously, you can do the manual, but why the AIML? AIML can do few things than a human can do. AIML can auto match the scenario based on the previous data. It is the most important thing for the AIML. And AIML also can predict what it can be in the future. But remember, it is in can be. It cannot say exactly. Because suppose I'm expecting like Pongal is coming in January in Chennai. Lots of people will come to the home. Lots of music, DJ is there. Lots of puja is there. So on that time, what happened in particular few areas, it might have a high rate consumption of the power. If I took that data particularly, instead of saying Pongal, I just took the date and time and the data. So what AI will do, AI will check on date and time and say this time Tamil Nadu, this area required a peak value. But it is wrong because the date particularly high because of the Pongal. So we need to justify the scenario based on the data and then we can process it with the AI. So that is the main power of AI. Now, why the visualization? Suppose I give you this data for analysis. To understand this data, I just forwarded to you. And please make me the analysis and tell me what is the load factor you can calculate or what is the prediction. You will say, sorry, I cannot understand. The reason behind it? Because this data doesn't looks like actually. Looks good to me. So instead, if I give you a proper structure data with a proper valuation format and a graph, specifically graph, on that time it will be looks like very good. And over there, our data science comes in our mind. Okay. So data science, what it says, let's see. Okay, I will go to the environment setup. Sure. So what will happen? Data science will analyze the old data and it will keep a flags. Flags is for outage. Now, here is a question. Why we keep the flag for outage? Because we always do the flag. Instead, we can flag the peak as well. But instead of flag picking peak, that I give you the example, like a Pongal date, because here you see in data, we put the date stamp, not the festival. So if we flag the peak, it can be the wrong sometime, wrong flag can be generated. Instead, we can say, okay, if there is a outage due to the peak, there will be outage. If there is a outage, that is the flag point. So whenever the outage is there, we need to put some extra power over there. Very simple solution I am driving at this moment. I'm not going to any complex solution. Suppose one feeder is outage, so I need to give them more power to the feeder. Very simple solution. So that simplest solution I am doing using the at this stage. I'm not considering anything. But before doing this one, we need to keep in mind some data science rule. Data science and AI/ML, specifically AI, application of AI to any system required a model. Now, a model can be performed good if there is a clean data. This few thing is very important. If you have a clean data, then only your model can perform well. Otherwise, not. Even if you use the latest technology like Power BI, integrated Power BI, on that time also you require a clean data because Power BI will show zero if there is a zero. Very simple. And nowadays in Delhi NCR, they introduce a thing called smart meter using NPCL. That is also happening. So this type of scenario we can maintain. Clear? So let's see how we can do it. So for this reason, for data science, we need to path a follow-up. So first thing, we need to set up our environment. So our first structure should be pandas, NumPy, Matplotlib, and scikit-learn. So basically, they are what? They are a library of a Python. I am using Python at this moment. As reason behind it, it's very widely available and very widely used in data science, and it is open source, obviously. So pandas is a library. We also use NumPy. Pandas is a library which will help us to read the data from Excel, rewrite the data to Excel or CSV or something like that. NumPy do our mathematical calculation. Matplotlib gives the visualization. The same way, the scikit-learn with some statistical analysis and this way. So now our notebook structure, which I will follow, will be first thing is load the data, second preprocess, third EDA, exploratory data analysis, then we make a model and then export the model. If I get time, I will show you after the clean data, means after doing the clean data, how can you see those things in a Power BI. Power BI is a very useful tool for us, specifically as it is specifically for engineering part. So I do not keep force on the Power BI, but if I get time a bit, I will show you the Power BI. So Power BI actually have a power to show a simple data with a multiple variant. We can change, we can do, we can interact with the graphs. That can be done in the Power BI. So this type of environment setup we will follow over here. Next thing, next thing is pre-processing pipeline. So when we have a pre-process of the data, we need to something. So if I say I will give you the flags. Flags I keep it for few things. That is, I will just need to mark over here once. Just give me a moment so that I can take another pointer. Yeah, so I make a flag on the outage. Then missing segment. So suppose if there is a missing segment can be happen for few reasons. Number one, maybe the IoT device is fault, maybe the connection is lost, because each IoT device also has a backlog that says that they require the internet continuously to work. So this type of scenario, we can say it is required. And that is the basically sensor health is maintained. So that's the reason if there is a missing segment, I will flag it and then I will say the sensor health will be tagged over there. A sanity clip is given over there. So power versus quality should be greater than 0. Um, Voltage always must be 180 to 60 because there is sometimes a single phase voltage issues happen. So this we need to keep on. And obviously our indexing will be timestamp because we have the data of timestamp. So we can set a frequency over there, how frequent it is happening. That I give you an example. In Chennai, we usually to have like 1 hour break, 2 hours on. So it's basically a frequency. We can say, we can easily say that. So that type of scenario, it can happen over here. So this is the thing we can do or we cannot do to use the um, Python or data science in a given data. Next part, we will come to the EDA consider. In EDA, exploratory data analysis, what we will do? We will do the slice of power, which can be seen in a 10-day duration. Then we will give you the average by hour or average by weekday, you can say. Then say relationship between a voltage and a load scatter. So what will be the relationship? What is the power portfolio trend is going on? Relationship in between like how the load, scattered load gives an high voltage or consuming a high voltage and when to put our alarm on. Suppose there is a voltage going on above 240. On that time, we need to put a alarm on for a uh, regular use, private use, home. If it is more than 240, maybe some important things like a TV, geyser, AC can run out. Is there any questions? Is there any question? Okay, sure. Thank you. That was my question instead. Okay, so this type of thing we can understand. And then histogram, one of the popular plot that we do. Yes, please. Someone raise a hand. I can see. Someone raise a hand. Is there any questions? No. Someone raise a hand. Okay, I will continue. If there's a question, let me know, please. Because I'm not sure that someone raise a hand, but what reason I didn't understand till now. Anyway, so that histogram, what we do basically, histogram will see with the time, what is the frequency, what is the outage frequency, what is the duration of that outage. That type of scenario, it required to know for us. And that is happened over here when you do the analysis the data using data science. And that the application of the data science in the field of smart grid. So we can understand before that. We also can perform a peak load scenario so that the if the high voltages comes in, at least your main appliance like fridge, TV, geyser, they do not destroy it. So that is also help for us. So few toolkit that we are using that I have a very simple thing, rolling windows, and standard deviation over 24 hours and 60 hours. Some lags we will check and just put all this. In baseline model, you can use a random forest, which is a very good model. Till now, I get a accuracy of 73 and above percentage, which is very good with a mean square error of 99%, which is 0.43% they cannot analysis, but majority of they can analysis. But major thing is data, which data you have. That is we need to figure it out. Let's see the part of a code a bit so that we can discuss step by step for the code as well. I'm taking this code inside of it so that we can discuss it a bit. After that, we will come to the scenario. So first, I show you the data, which data I am using. I'm using this data, this raw data. And this raw data basically says the whole thing, the solar power, whatever it is there inside. Then I'm reading this data over here and I just need to upload this data for a while. I'm using Google Colab at this moment. You can also use the Visual Studio Code, which is similar. So you can use any one of them: VS Code, Jupyter, Google Colab. It doesn't matter. I'm using it for simplicity. There's another reason, maybe something to install. That's the reason. The first part is the import part. Though I keep the TensorFlow import over here, I use it at the end. I use a simple CNN model as a transformer model specifically because it is one of my part of the research it was. So I use a transformer model. I advise my student to use a transformer model. They use it. So I keep this path in top. So it's just keep it at this moment. We will discuss it later on. The first thing, as I told you, pandas I use. So I import the pandas as a PD. At the end of this session, I will give you a small tricks to use this four thing, not four actually, this five thing in a single command. You can run this five import in a single import. It is possible. But remember, this is the aliases that we know that pandas always called as a PD, like we all have a pet name. So this person, X person will call as XY. So that always happen. So like I have lots of pet name even. So this type of scenario can be happen. So this is the aliases. So import pandas as PD means if we call PD, we actually call the panda. If we call NP, we actually call the numpy. If we call PNT, we actually call the matplotlib deep.python. If we call SNS, it actually called the Seaborn. Matplotlib and Seaborn, they both are the graphical designer, but Seaborn is far more better when it is statistical analysis comes in. But Matplotlib is the backend. If you see the C1 code, at the end, you need to use the PLT as a plot. So that is happening. Then from scalar preprocessing, we use a standard scalar. We take the 10 split, train test split, so that our whole data can be splitted in two parts, actually three parts: training, validation, and testing. Now there is a question can become seen sometime. Some people have a mind in that. What is the in between the validation and test? Always simplified this scenario as per my understanding, obviously. I ask my student to do the similar thing. So what is training, what is validation, what is testing? It's a very interesting part for me. What I do, I suggest them. Training is basically when you are teaching. When I am teaching to you, this is basically the training. I told to my student always. Then there is an exam. Exam is validation because I am setting the value based on ITC. And what is the testing? Testing is specifically when you go to the job, you get some new thing to do, and how well you are performing based on your validation. That is your testing. So testing basically is to do it in a unknown data. But at this moment, we are taking the all data, means all full CSV files, will be converted to 80-10. So 80% is a training, 10% for validation, 10% for testing. So that is always keep. Then we come to the matrices, which is basically the matrices is basically for what? When you train a model, when they get a feedback from the training, how well your model is performing. So basically, if we say it in simplified one, how well you are justifying your answer in a real world scenario, that we are checking. Over there, we are taking confusion matrix, classification report, ROC curve. This thing we usually take in real life scenario. Then TensorFlow. TensorFlow, I took it over here to justify the transformer because it is my practice because of my 8 years of working career as a industry. It is my practice that I always try to keep all the necessity input in top. This is my practice. Bad practice or good practice, but it is a good practice actually. It is not a bad practice. So always we need to keep a synchronized or a proper showcasing way so that if there is an issue of the importing, I will check the top only. I don't check everywhere else. But I know what can be done. So this kind of thing. So that I will do is based on this. And then Keras backend, I call it. Keras backend, I call it for the TensorFlow that basically use when we use the transformer model. Now, Why we want to use transformer? This transformer and the electricity transformer is not the same. So why in this case we will use transformer? Can anybody say me? Can anybody answer me about that? Why we will use the transformer in this case? The very simple reason, because I'm giving you the reason with a simple analysis. The transformer here, because smart grid signals are multivariate, and also it is a long range depending on the context and reach. It has a calendar case, it has an outage, it has a weather, it has lots of things. So in this long range of temporal patterns, hourly, daily, weekly, seasonal, on that time many variables, many shifting elements, multi-horizon for forecasting, then there is an anomaly detection, then parallelism scalability is there. For this case, we can do a deep learning based technology to understand more depth one, then it is a transformer can be helpful. Clear? When and is a more depth transformer specifically used when there is a very depth in the search, depth in the data. So we need to know more depth in a data. So on that time, transformer can be very useful. And that's the reason over here we need to use transformer. Another one question is there. Why? Because if you see in here also, I write full anomaly detection workflow. Why this anomaly detection is required? That is one question comes in our mind. But we understand what is smart grid, what is the application of data science in smart grid. But why in data science application we always talk about the anomaly detection? So anomaly detection, it is not essential, but it must have. Very controversial word. It is not essential means it cannot be had, but I will say it is essential. Must it not essential, but it must have. The both things are true. Why it is matter? The first thing, safety. Safety for what? Safety for equipment failures. Safety for overheating. Safety for arc faults. Arc faults means like a lightning or something like that. Fire. So this type of thing can be reasoned by the anomaly. Then reliability. Saidi and Safi were preventing the cascade outage. If there is a outage, means we predict a outage can become in few hours. We can slowly increase the voltage over there so that it can be covered. The power can be increased. Asset health and maintenance that I told you, loss reduction, one of the major thing. Imbalance phase sometimes cost you a lost technical loss. Technical loss is like a meter hampering, feeder hampering, transformer hampering, energy theft. On that time, we can say this scenario can also anomaly. If we remove the anomaly, you can detect the anomaly. Our model can work more robustly. Then, if there is any theft, we can give a priority to the customer experience so that the electricity theft can be minimized. So this type of scenario we actually take in inside of the anomaly, and that basically is also required anomaly for the KPI to track. KPI means how much time to detect a problem, how much time to detect resolve the problem. Means suppose you are in a dark area, means your area become a power outage, and you are calling to the uh, power meter means who are giving supply, and you're asking them for help, and they are saying, okay, I will come after 2 hours. Then I will say I will come after 3 hours. I will come in 10 minutes. Then I say I take 20 minutes. So on that time, what will happen? You will be like a notified, like you say, what is happening? It is not true. So these type of thing can be avoided by the Anomaly. Because nowadays, lots of power companies are in private sector. So in India, specifically, I'm talking about. The private sector means KPI. KPI means how quickly you satisfy the customer, how quickly you solve a customer problem. This thing is noted down, and that actually help us to give a power supply company. So if we see previously in previous era, previous month, you can say connecting it in previous time, we usually it is happened like suppose you make a complaint, it takes 2 to 3 days time to have it on finish. But now, as the company grows, they require to do it very quickly. And that thing only possible if and only AI is behind of it. And that's the power of it. AI can do this thing for you. So let's connect it. Okay, starting. Now I'm just making print and ways to read the file path, obviously. And then I run this file. So if I say first 5 rows of data, they give it with a timestamp. 5 rows, I'm just showing it so that I can understand my CSV written properly. I can cross verify definitely. So if you see 232 in volt, yeah, it is right. So it's just an so I'm just showing the df dot head, nothing else. First five. Default df dot base is basically 5 set we say. We can make more actually. Then we come to the data cleaning. Data cleaning is basically says it's required. As I told you, I am putting a flag on outage, red flag on outage, as well as if there is any missing data. Because missing data lead to two parts. One is missing data due to some sensor error. So sensor can be investigated. So this type of scenario, suppose a particular area feeder data is not coming for a long time, then I can expect the signal of this feeder is lost. So according to that, I can definitely take a action to check the sensors. So that thing is a power. Then I will do the first row checking, and then I combine anomaly to column all zeros being created. So anomaly detection without a true level is useless. So we need to make that true level first. So I just do it. So we can see missing values before cleaning, all are almost zero. So there is a no missing value. And very good news that there is no missing value from the smart grid that I am very much happy with. So missing value after cleaning of zero. So that is also very good. Then data types, which type of data type is there that is given over here. We can show it as a df.describe as well. That also can work the similar way. If we over here df.info, okay, df underscore base. So all are float or integer. So there is a no string part. That is a very good scenario. There is a no object. If it is an object, then it is a string. So all are float and integer. So it is very good. But there is a float. Okay. And we need to also need to check and df underscore processed info. Yeah, they are all same. No null. Null count is 0. It is good. Yeah, it's all good. Memory user. Okay. Now I'm coming to the feature engineering. Why we did the feature engineering? It is a part of EDA. preprocessing, feature engineering, the part of the exponential analysis. Why you require the feature engineering? Few feature may not require at all for processing the data, and few feature might require that you don't have at this moment, but that we can calculate, like total cost. Suppose you make a plan that a house, as a smart grid engineer, you make a plan that a house can use up 150 rupees per day, 150 rupees as a cutoff. So you set 150. So we need to calculate how much cost is there, but how much consumption is there. So here there is a price is given and the power consumption is given. So we can just multiply up. So that can be a useful part if it is required. So this type of scenario, so electricity price, yeah, electricity price is given over here and how much usage is given over there. So we can say, okay, we can stop him after that. So according to that, we can plan our grid. How? Suppose we stop the main plan, means the main power plan, which is the main auxiliary plan, a main power part, like using any plan source. But when they cross the 150 rupees balance, they will go to the solar power. So I will change the void. So that is the tricky grid change can be done over here. Usually it's also happen in our mobile system, right? In mobile system, suppose you have a data of 5 GB or 10 GB. On that time, what happens? After completing the 10 GB, your speed become low. So that is interesting part. That is happening. So that's the scenario can become in this feature engineering. So this feature engineering also helps us to hold a proper scenario, to hold a proper work done for your database. So if there is anything required, we can check it out. So let's see what is required over here. So we give the core numerical features that is always required for us, humidity, temperature. So now your question can be why we including humidity and temperature in our power data sources. Because suppose there is a very hot in your area, particularly in India. Did you use AC? Did you use fridge? And I say yes. We will. Lots of things need to be kept. But suppose you are in a very winter zone, specifically in Delhi at this moment is 16 degrees centigrade. So with a high pollution, what you will do, you not require AC at all. You might, due to the pollution, you might require a fan for a while, but after that it is need to be stopped. But at evening, when it is a 9 degrees centigrade, you require a heater. So this type of analysis, critical analysis, can be done using this AI. So that I did. So now applying feature engineering to the existing numerical features. The existing feature is this one, and then added some feature we are adding. There's a lagged feature. So rolling mean, rolling this type of scenario we are adding over here. So also we are column some to exclude like overload condition, transformer fault, combined anomaly. These few things we are to be ruled out. So I'm just running this part behind. Data scaling complete. So I scale the data. Then I show the data as per my TF dot few thing. So if you see, I mark everywhere like step 7 data scaling is done. So feature X scale save after scaling this one. Label save this. So save basically says how many data we have. How many we are processing. So this type of thing we did over here. I did the step by step so you can see how the feature engineering is done, how many frames is done and everything. Then in come to the isolation. So this isolation part actually says to make means with the engineered feature, isolation basically says engineered feature is separating from training and evaluation. That part. Basically, we're scaling up and down to make it some kind of like a constant available. We are doing that. So let's see. Some, So precision recall curve isolation forest is like this. General curve area is 0.13. Not bad. It can be reduced a bit. ROC curve is almost fitted on the line. So ROC is good enough, but it need to be better enough actually. Because ROC score is 0.50. It must be about 0.80. Very low. We need to repolish it. We need to fine tune the scenario. Normal and anomaly precision recall score is given this. So it is based on the isolation forest. It's a part of random forest basically. Then now after doing this one, I want to use a scenario which is a transformer comes in your mind. So let's see. So here is save it. This is the classification report code. This is the confusion matrix. It confusion matrix shows us how many actually they did correctly. So if we say actual normal, actual anomaly, is they are very good enough in the number, very good correction. Correct is there. Error is very less, like 2170 and 5945. Good enough. But false negative actually a little bit of high, which you need to the the true negative need to be increased. That need to be done. So that's the matrix is saying to me that according to the random forest model, isolation forest, ensemble model basically, this is ensemble model, multiple model mixed. This isolation process, we are having an issue with true negative. True negative means where if there is an anomaly, but still it is saying it is not an anomaly. So on that time, it is happening a issue. So these type of scenario, we need to check it. So this error can be found in all of the machine language. Even if you use the linear regression, you can use logistic regression, you can use XGBoost technology, AGBoost technology. But most of them, you will get this type of error because of some reasons. So that way, I'm not going in depth the mathematical part. So if I go then it will take another 3 to 4 hours for analyzing this mathematics only. So instead, I'm just to give you the overview why it is useful, and definitely I will. If it is required, you can request me. I will share this file with you. If we can see, the association forest ROC matrix is not too good. 0.50 is nothing actually, and precision recall is not bad. Now I am giving a auto encoder facility with engineering feature and training and evaluation. So auto encoder basically automatically choose some few features that is very much required for it. So auto feature integration, we can say we are need to taking. So I'm just running it, then I will talk about it because it will take some time to do. So I will run it fast. So it is doing very quickly. Thank you for that. When doing the purpose. Then I will put the let's run it. Then I will discuss it definitely. It is running. So just give me some moment. So here basically if we see, I put a simple input layer, then I put three different layer, dense layer, and basically that's it. Very simple auto encoder process. It's very simple process, simple model. I do not keep too much of like complex model or something at this moment. I just keep a very simple model, one input, then three dense layer, and last one is a classifier. So what it will do, it is basically says that if we reconstruct it, then uh, it is saying that if there is a MSE loss is high, then we need to reduce it. So if the mean square error is high, mean square error is very high, then we need to reduce the mean square error. So that is actually our any type of ML model we are doing. We are actually reducing the error. That specifically we are doing. Error for what? If your model says something wrong, then you need to reduce it. And reduce to tends to 0. 0 is not possible, so tends to 0, you can say. So here, if we see our specifically our confusion matrix says our model in the random forest model, what happened? Does it have issues? Actually, true negative getting less than I expect. The accuracy is 84, but still true negative, specifically anomaly case, if one score and precision is low. So still my model cannot analyze the anomaly detectly correctly. So normal case is predicting very well, but anomaly cases cannot detect by the system. So if we see here it was 329 correctly predicted, here 323. So actually is reduced a bit. Though all are reduced, I guess. Yeah, this is reduced. This is increased. So true negative and true positive, false negative and false positive is increased by using this bottleneck system. So basically what I did, I just keep it very simple. So our loss is, if I say the validation loss is almost tends to 0. So that means our system cannot get training properly due to some reason. So what is happening? The data is saying as per this graph, our model is very correct. But as per the confusion matrix, it's not too good. So we need more sophisticated model to analyze correctly of the situation. So that the scenario, how can we do it? That is comes should be in our mind. So our mind should figure about like if I say at this moment what is happening to the model, I make a simple bottleneck feature that actually compress and reconstruct, and then I will use the layer normalization or so that we are doing it very clearly. But the scenario is still I do not put any transformer at this moment. I just put a auto encoder. It's a kind of like a 1D CNN, you can say. Simple auto encoder architecture, I put it over here. But in this case, I can see our matrices goes less. So it is basically improve the robustness, but cannot exact what we are trying for. So if we see a little bit of higher side, if I go over here, normal was 87, 85, 91. Yeah, it's good enough, but anomaly is still is bad. Why it can be? There is an issue of AI. As I told you earlier, that AI is based on the data which is available to you. Now, maybe in our data set, anomaly data is not too available. So that can be the cause of a sensor ticket. So that we need to keep in mind. So this type of scenario can be triggered. So for this reason, I use a transformer model. Now we need to see how this transformer model actually give you a better solution or not. So data science is all about a science. It's a kind of like a research. It is not like there is a I'm giving a problem and this is a solution. So usually a data scientist need to work on what is happening on what is at this moment. So based on that, the data scientists need to design what it can be happen in future. So these perspective or these precisions, the data scientists must have in them. So in order to do that, I am doing at this moment, I'm just doing a simple transformer, adding a transformer in the previous single dense model. So what I am doing, I am doing a more custom layers, which is transformers basically, with a dropout and residual layer with a normalization. So model architecture, what is happening? A encoder ISH that is already defined in earlier, along with a tiny decoder. So here is a encoder decoder transform, encoder decoder relationship we are building. So it actually it should be minimize the loss, and it also increase our MSE, mean square error. That basically we will reducing the error a bit, so it must be says more correction in a correct way. Let's see how it happened. So again, there is a training part is going on. It takes a little bit of time because it has a transformer block and the token positioning embedding and then flattening there. So it will take some time. So what I will do, I will transfer from here to T4. So that I can use T4. Just give me 2 minutes so that I can use the T4. Because without GPU, it can be the issues. Yeah, it is connected. So I just need to upload this file once more. Yeah, it is uploaded. Now we'll start this to run all and then just give me 2 minutes. It will run all the model. Just allow me 4 5 minutes so that I can show you. Just give me a few minutes. It is running. Find an error. Sorry. Let's see which error. Okay, now I am putting a training of encoder, transformer auto encoders. It will take some time, bit time. First I tried 100. I keep 150. The reason behind it. First I tried 40, and I before coming to this lecture, and it says a very bad result. So I increased to 50, 100. So 150 give me the reasonable result. So I keep it 150 with a early stop. Early stop means when a particular validation module is not changing a bit on that time, we can do the early stop of the training so that it will not lose our time a bit, time or something like that. So that basically our target to do. So let's see. So let's complete this training for a while so that you can see how it is going on. So here, if you see, I just give a very simple scenario. One input layer along with a transformer block, then second transformer block, and then flatten layer, dense layer. So basically where we kept in the simplest convolution layer. So just to make a little bit of complex with it, two transformer block, nothing else. I will not take much more time, so just give me some time to finish this training part. Then I will, then I'm just closing the session. So just give me a few moments because training always take time in email. Yeah, email, all part is about the training. Though I promise you to give you a feedback of Power BI. So I will show you a Power BI simple uh, GUI. I will not do with this data at this moment, but I will show you the previous data which I did. Then I will show you how Power BI can help you to show something. Still, I will try based with this Power BI. In the meantime, I will prepare the Power BI. Power BI is a Microsoft software, and the Power BI desktop is available. You can download from the Microsoft website. So if you just go to the Google and say Power BI desktop, so you will get this website. You can just go to this website and download it. Very simple. Um, it is really a very useful tool. I will show you now. So you can download it for free, and you can use it as a your uh, visualization tool. So how? Just open. Uh, I used previously. Should I show you first this? Yeah, I will show you. So previously I use a simple data model we make. I make it during this process of FDP. And what was there? It is saying that basically how the sales going on. at the time of mapping and everything. So just it will, I will show you the first dashboard, then I will explain it day by day. So in the meantime, the training will be done. So I'm just waiting for this. So if we see this, the revenue part I give it is a kind of like a one channel dashboard for everything. So it is a, from other data I told you. It is for the other data definitely for this. So what will happen is, suppose I want to see what how many cells is there in Bengal. I want to click on Bengal. I can see it. I can see it. Every figure is changed with day by day. So that is the, so each graph is interactive with each other graphs based on the data you give. So that is the power of the Power BI. So now if I do it for this, so I just open it, open a new one. So I go home, blank report. So blank report always looks like this. I'll show you. It might take some time because Power BI always takes time. So here I'm putting a get data. I am using CSV, so you can use anything else as well. CSV. So then so this data, the training done. The training is still going on. Learning it is very less, 0.0005. Which is not bad. Yes, true. Understood. What is the output of it? Is there any error? One. So, to make one simple and over here, just I just made this file. So some fast processing 2 minutes so that I can show you. How. So, okay, this is some check the box. So here I just make it load. Digital loss is done. I go to the MB data set. It will take some time. Because I'm trying to do the training once again because it has an error in the server. So the GPU is died somehow. So what I do, I will put it run all over here. And till that time, I will do the power play. So this one I will close. I come, see, there is came to this one. So now I make another table so that my date table it can be. So I'll make a new table. Here is the date table. Table name smart grid. Timestamp. Now just come perfectly. So I took the timestamp over here. So here I can make it as a date. So I make it date step done. Now I need to make a relationship between these two. So here new relationship. Here you can try one with the auto detect. You can try it, but not always work. Found no new relationship. Okay. So new relationship we need to find it. So here I choose this from table date to table smart grid. One too many single. That's it. So it's basically makes a relationship with this date so that I can understand. So if you little bit of is a kind of like a SQL query, very simple SQL query. So I just want to uh, do some, you know, measure. I'm just taking a new measure over here. Yeah. So here I put so total. Okay, anomaly threshold is not defined. Okay, maybe I took the wrong folder. Okay, here what we can do, overload reactive in power voltage processing. Okay, I just want to show you as a simple graph or a simple voltage fluctuation with the time. So if I go to the report view and here, if I add a simple graph, a line graph, and here in X field, I give this data, and X is a timestamp, obviously. So I put month in X-axis and Y-axis I give the power panels. It will come like this. So if I give tip, humidity, I take it in the tooltip. So what will happen if I go to the mouse on it, it will show me. So that is actually the power. And also we can do something like we can do much more calculation like anomaly scan and everything. We can show a line chart, okay, of timestamp with a primary target of TAE. So like if I say time, I can make a line chart. Here x-axis can be my timestamp and y-axis can be my power consumption. So see, so from the 24, 25, I can see the power consumption is going down. So we can see it like this. So here what will happen if I put a slicer in top, if I just put a slicer, or also you can put a card over here. So sorry, this one, I will put a card. What a card will do, I will show you. I will give you the and then in down I put a slicer and I put timestamp. Now if I click on this, I get quarter one. So if I click quarter one, see the timestamp is changed. All things changed. If I put quarter two, all things changed. If I go 24, I create contour one, you can see. If I click this, if I remove this, I just can get the March one. I can see what is going on with the Power BI. I don't need to do anything. So suppose I'm okay, March in this 24 and same thing. I want to see the March 25. So we can see the comparison. So these type of scenario we can do using the Power BI. If we have a feeder ID over here, we can put this feeder ID over here. If I put a, suppose I put one more extra card, one new style of card is also came over here. So here you can place it like this, and here you put a voltage fluctuation, and in tooltip I put temperature. So in tooltip I put temperature, and also I will show you is there any overload or not. So see, in a single card I can see the voltage and overload, and also means the cross report and categories. We can see the timestamp is a category. So here, if I make it a little bit of large, you can see like this. So that is the power. That is the power comes in. So suppose if I put over here, see everything is changed. So I can see in the Power BI, I can see to keep my power bank, to keep my grid on or off, what I need to do, I can see it like this. If I have a location address, I can see the location wise as well. I do not have data at this moment with the location base. If I have a data, I can show it as a location base using this map. There is a map, and if I put this map and I put the location data, it will show the location wise data as well. So this is the power can happen of the Power BI. And that is the power of data science can do in the grid analysis. So data science, specifically in Python, we did the preprocessing, we did the ID analysis, we did all other things. Along with, when we put the data in Power BI, we can see it properly so that a different person can easily understand what is happening inside. And I hope you can see it, how clear it is, how quickly we can run a quick check with the date with a slicer. We do not require anything in the back end. Obviously, today I am not able to show you. Here you can publish it and it will publish to the public. But in details, obviously, in my edutech company, we give the training about it, that how to do in Power BI integration with the Python backend. So whatever I run in Python in separately over here, this can automatically run to integrate with Power BI. It can be done using the Fast API, using the Fast API or using the Flask. So that we do in our company. We teach them, we give the training. So there are lots of things we do in this basically. So that is the power of data science or a AI system can help you. So now I'm coming back to the little bit of the scenario of over here. So I give you these details. So here we do the anomaly detection. So anomaly detection, what we do, basically safety reliability asset that is required, that I told you why we required it. Then we do three type of anomaly here. Anomaly detection using isolation, autoencoder and transformer. LSTM I didn't show you, but you can try it. What is happening? Isolation forest, two autoencoder actually result destructive, but in transformer it's supposed to be result increased, but due to the lack of GPU, it is not accepting happening in the Google Colab. So it basically says a from a simple to a complex, where quality is our major measurement thing is quality, and our precision to make the high precision make our trusted system. So precision is our main thing. So true positive is the best thing. for us, and that we almost achieved. And next, as per the anomaly lesson I told you, the Power BI can be a most interactive tool that you have in your life that can show you the anomaly and the load overview at a single click for all the session. Clear? So this thing I show you practically a bit in a short time. So hope you enjoy it, and I'm really thankful for the SRM and the other team member for welcoming me and inviting me for talking of this session. If there is any question, I'm open for you at this moment. Thank you.